Hey everybody, welcome back. We're going to get into a new section where we're going to learn how to solve problems. And one of the things I want to teach you now is one of the techniques we do that, which is called dimensional analysis. So dimensional analysis is really powerful, and it's wonderful because it allows you to take a number in some kind of units and convert it into another kind of unit. So for example, you can convert inches to centimeters, or you can convert kilograms to micrograms. So there's a lot of cool stuff you can do with it. So this is dimensional analysis. And it's also called the factor label method. Okay, so right after I just wrote that, guess what? I'm going to erase it. So I don't think it's important that you learn the terms of what this is called, but I think what we should do is just go straight into solving a problem and see how it goes. Okay, so let's just give you an example of this dimensional analysis. So for example, I have as a first practice problem, how many grams in 3.14 kilograms? What I do to set up the problem is I write up what the information I have, which is 3.14 kilograms to start with, and then I'm going to put a times sign here, leave some space, and then I'm going to want to get an answer in grams. Okay, so how do we solve this problem? So one of the things you'll have to know is the conversion factor for getting kilograms into grams. And so what you might remember is that 1,000 grams is equal to 1 kilogram. So this is sort of an equality. So one of the things I want you to do right now is just take a look at this equality and think of two fractions you can set up from it. So one fraction you can set up from it is where you put the left number over the right number. So I will do that here, 1,000 grams over 1 kilogram. Or you can put the right number over the left number. So you have 1 kilogram over 1,000 grams. So there are two fractions we potentially could use to solve this problem, but we're only going to use one of them. So I'll call the first fraction A and the second fraction B. So your goal in this problem is to use one of these fractions, A or B, such that kilograms in the numerator in the problem cancels out with kilograms in the denominator in the fraction you're going to use, leaving a grams in the numerator. So you have to choose either A or B to get kilograms to cancel out to leave an answer in grams. So let me first give you what the wrong answer would be. The wrong choice to make would be fraction B. Let me show you why. So what I'm about to write is not quite correct. I'm just kind of going through it so I can show you what's wrong with it. So if we had 3.14 kilograms and we use fraction B, which is 1 kilogram over 1,000 grams, you would get some kind of number, right? It would be 3.14 times 1 divided by 1,000, but it wouldn't be the right answer. Let's talk about why. So we have kilograms here in the numerator, but we don't have kilograms in the denominator here. We have grams, so they cannot cancel. So the units here, the answer would be in kilograms squared per gram, which makes absolutely no sense. And so you really cannot use fraction B for this problem. So instead what you want to try, let's just try fraction A and see how that works out. So fraction A, I'm going to draw it up here, is 1,000 grams over 1 kilogram. Now let's see if units cancel out. So we have kilograms here in this number in the numerator, we have kilograms in the denominator, so the kilograms will cancel out. Here we have grams in the numerator, so the answer will be in grams. So let's go ahead and do the math. So if you take 3.14 and multiply by 1,000, I get 3140 as a number. But the thing is, we're not quite done with the problem yet because you have just learned how to use significant figures. So we want to make sure and confirm that this is the answer in the correct number of significant figures. So how do we do that? So we note the number of significant figures in the numbers we're dealing with here. So in the left number here, we're having 3 significant figures. Here with the fraction, it's a little bit trickier. So you might immediately say, oh wait, I only see 1 significant figure in 1,000. That's not quite right. what you have to remember is when you have a conversion, a metric conversion of 1,000 grams in 1 kilogram, when you have an exact metric conversion, those numbers will be exact numbers. And whenever you have exact numbers, what you should do is assume these numbers have an infinite number of significant figures. So we have 3 significant figures. We're multiplying with a number that has an infinite number of significant figures. So you're still at 3, dividing by 1, which also has, that 1 has an infinite number of significant figures. And so basically, in the end, your answer needs to have 3 significant figures. So you can write 3,140, and when you don't have a decimal here, that suggests that this 0 is not significant. So there are 3 significant figures here. Another way you could write it in scientific notation. So it's 3.14 times 10 to the 3 grams is the answer. Okay, so let's do the next one. So how many quarts in 3.5 liters? Okay, so let's set up the problem. We have 3.5 liters times something, some kind of fraction, is going to give you an answer in quarts. So what we have to do is think of the right conversion for liters to quarts. And so this is one of these conversions you have to memorize, unfortunately, for this class. So you may have to remember that there are 1.06 quarts in 1 liter. Again, in your mind, you can maybe set up the 2 fractions that you can choose to use to solve this problem. So one fraction, we'll call it A, is 1.06 quarts over 1 liter, and the other, we'll call that A. And then there is B, which is 1 liter over 1.06 quarts. So the question is this: which fraction do you use, A or B, such that liters here in the numerator cancels out with liters here in the fraction in the denominator, leaving an answer in quarts? So it looks like you want to use, again, fraction A. So it's 1 times 1.06 quarts over 1 liter. And so what you can see is liters cancel. Now the math, what you would do is, you should have said this before, I'll say it now. When you're handling the math, what you do is you multiply all the numbers in the numerator, and then when you drop down to the denominator, you divide. So the math is 3.5 times 1.06 divided by 1. So it's basically 3.5 times 1.06. So it's 3.5 times 1.06. So the number I get is 3.71 quarts. Now we have to be careful. We have to get this into the correct number of significant figures. So let's see how we deal with that. So we have 2 significant figures here. With 1.06 quarts in 1 liter, the 1.06 quarts is not an exact number. That is an estimate. So if it is not an exact number, this will have 3 significant figures. Here, this is 1 would be an exact number, and so it's an infinite number of significant figures. So we have 2 significant figures multiplied by a number with 3 significant figures, and therefore, you might remember with multiplication, the answer will have as many significant figures as the number with the least number of significant figures. So if you have 2 significant figures here, our answer, 3.71, must be rounded to 2 significant figures, and so the answer will be 3.7 quarts. Okay, let's go to the next one. I'll try to go a little faster. Okay, so the next problem is we're going to take here 51 centimeters, and we're going to get this into meters. And so we need to know the correct conversion to get centimeters into meters. And so what we're going to do is there's going to be 10 to the negative 2 meters in 1 centimeter. So if there is 10 to the negative 2 meters over 1 centimeter is one possible fraction, or 1 centimeter over 10 to the negative 2 meters. Okay, so what you're going to have to do is pick the number such that the centimeters cancel, give you an answer in meters. So it's 10, whoops, finger doesn't work well, does it? Use the eraser. So it's times 10 to the negative 2 meters over 1 centimeter should be our answer. Okay, so the centimeters cancel, giving us an answer in meters. So it's 51 times 1 exponent 2 negative. Yes, so it's the answer should be 0.51 meters. And so let's check significant figures. So we have two significant figures in 51 centimeters. So there are 10 to the negative 2 meters in 1 centimeter. These are exact numbers, and so you should assume they have infinite significant figures. So it's two significant figures times an infinite number of significant figures divided by an infinite number of significant figures. And so we should have an answer rounded to two significant figures, and so the answer should be 0.51 meters. Okay, let's move on to the next problem. I'm going to try to go a little bit faster now. So the next problem is we're going to convert 2.5060 pounds, and we're going to get that into grams. Okay, so you have to remember the conversion between pounds and grams. So 1 pound is equal to 453.6 grams. And so I'm not going to write out the fractions. Hopefully you can do that in your mind. But what I want to do is try to get pounds in this number here in the numerator to cancel out with some kind of pounds in the denominator in the fraction, leave an answer in grams. So it's going to be times 453.6 grams over 1 pound. So pounds cancel. Let's see what I get with the math. Yes, and I get 113.6.7216 for the answer. But again, that's too many significant figures. We got to convert this answer to the correct number of significant figures. So we have 5 significant figures here. We have 4 significant figures here. And so we're multiplying these numbers, and so therefore the answer should be in as many significant figures as the number with the least number of significant figures. And so this should be rounded to 4 significant figures. So the answer should be 1137 grams. Okay, next problem. I think I need some Windex. This will have to do for now. Okay, so let's say you have a piece of metal that is 0.5200 inches long. How many centimeters is this? All right, so this is going to be 0.5200 inches long, and we have to convert this into centimeters. Okay, so you might remember that in 1 inch, there is 2.54 centimeters. Now, in your mind, I'm hoping that you can create the two fractions and pick the one such that the inches here in the numerator cancels with an inches in the denominator, leaving centimeters in the numerator. And so what I'm hoping you'll write is 2.54 centimeters over 1 inch. And so inches cancel, and then looks like you get an answer in centimeters, so it's 0.5200, which is 4 significant figures, times 2.54. We'll talk about the number of significant figures in 2.54 in a second. And so the answer I get on my calculator, if I can read this, yes, is going to be 1.3208. Now the question is, this number, how many significant figures should it have? Well, there are 4 significant figures in 0.5200, right? And so if you look at this equality of 1 inch equals 2.54 centimeters, this is the weird one. When you convert inches to centimeters, that 2.54, you might think that is an inexact number. It's actually an exact number. And so 2.54 here is not considered to have 3 significant figures. In fact, it's considered to have an infinite number of significant figures. So really, if we have 4 significant figures here, 2.54 in this equality has an infinite number of significant figures. Other qualities are going to be different. And then 1 has an infinite significant figures. And so the answer should be in 4 significant figures. So the answer should be 1.321 centimeters.